All right, I'm going to work through a problem for the final unit for Math 56. And these are mostly algebra, and there are many word problems. So we'll be looking at those one at a time. This first one says, find the sum. The sum of three consecutive natural numbers is 1,116. Find the numbers. All right, so we need to encode this sentence in math. So they're talking about three consecutive natural numbers. So natural numbers are usually the counting numbers. They don't always include zero, but we'll think of like 1 through 10,000, numbers like that. And we're going to use letters to represent them. And we're going to say that we'll start just by saying x plus y plus z is equal to 1,116. And that's all the information they give us. And what we need to do is find a way to encode these variables so that they're all defined in terms of the same variable, right? So right now we have three variables. That's too many to solve this equation with. But if we can define them in terms of one of them only, then we'll have a better chance. And so a key term here is consecutive. Consecutive numbers, they've got to go in a row. And what separates consecutive numbers? What separates 1, 2, and 3? How are they different? Well, each one is one higher than the one before it. So that's something we can work with. If we wanted to define x, y, and z over here, we could decide x is going to be equal to x, and y has to be one more than x, or it could be one less, but we'll do one more. So we'll say x plus 1. And z is going to be two more beyond that, one beyond y. So we'll define z as x plus 2. And being able to define these terms all in terms of x, we've got x here. This gives us just one variable to solve for. And now we're going to substitute these values x, x plus 1, x plus 2 for the x, the y, and the z in this equation, okay? So x is the same. We're going to say x plus 1 plus x plus 2. So basically we've just substituted these numbers in for x, y, and z, and that's going to be equal to 1,116. So first thing we want to do is combine like terms. These are consecutive numbers. Sorry, my writing's bad. We'll rewrite this. We're going to combine like terms. So we want to combine this x and this x and this x. So x plus x plus x. These are all going to come together to give us 3x, right? We've got 1, 2, 3 x's, so we abbreviate that 3x. And then we've got 1 plus 2, which is 3. So now we've combined this expression. We've simplified it into 3x plus 3, and that's equal to 1,116. And now we just solve for x, which is the same thing we always do in algebra. So first of all, we're going to start working from outside the outside edge of x, which is this plus 3. And we're using the inverse operation. These are some key words. Inverse operation. If you look for these at Khan Academy, consecutive numbers or consecutive number problems or inverse operation, they will explain what that is. Basically, using inverse operations removes the guesswork. We have a plus 3. We're going to do the inverse and take a minus 3. And we're going to subtract 3 from both sides. This side they cancel out, and this side they leave 1,113. And we can rewrite our equation as 3x is equal to 1,113. And we still want to isolate isolate that x. So let's see what we can do. Now we have x being multiplied by 3. So again, we'll use the inverse operation, which is division. The inverse of multiplication is division. And we're dividing by the same number, 3. And we have to divide both sides by 3. Or it won't be an equation anymore. So 3 divided by 3 gives us 1, which means 1x, or it just leaves x. And then 1,113 divided by 3. Let's see, 3 goes into 11 3 times. That's 9. And that leaves 2. Bring down the next number. 3 goes into 21 7 times. 7 times 3 is 21, leaving 0. Bring down the next number, 3. And 3 goes into 3 one time. So this is our answer. And we have x is equal to 371. So we have solved for x, but we're not completely done yet, are we? So in the first step up at the top, we were translating their words into algebra, into letters and numbers. And in the second step, we had to apply some of our own knowledge here. How can we analyze the words in the problem in a way that we can make them all we need to have the same variable. So we were going to define y and z in terms of x. So we did that. X was always x. Y could be 1 more than x, and z could be 2 more than x. And so we rewrote the equation down here. X plus 1 plus x plus 2. We combined like terms to get 3x plus 3. And then we used algebra to isolate x and solve for it. So if we follow this pattern, x up here, x is equal to 371. And y is equal to x plus 1. Well, that's got to be 372. And z has to be equal to 373. That's x plus 2. And then when we add all these together, we should get 1,116. So we can just prove that this is the correct answer, if it is. So 1 plus 2 plus 3 is 6. 7 plus 7 plus 7 is 21. Carry the 2. And 2 plus 3 is 5, plus 3 is 8, plus 3 is 11. So we do get 1,116. And so we can put the numbers in here. 371. 372, and 373. All right, let's try that. See how we do. Okay, looks like we got that right. And so what I'm going to do is click this. You can pause the video after I click. I'd like you to try and work this problem using this technique with these new numbers. So pause the video and try to work this problem using 810 as your new number.